Disturbing a chemical equilibrium. A chemical equilibrium is when the rate of the forward and the backward reaction are the same. The general reaction scheme at chemical equilibrium is right here. Our reaction from the experiment is a homogeneous reaction because the reactants and products are at the same stage, which is aqueous solution. And the concentration of reactions and products remain constant, but not necessarily the same at equilibrium. But the reaction must react in a closed system. So an equilibrium expression is an expression of the equilibrium constant K, which you see right here, which generally looks like this and constructed by the general reaction scheme. Our equilibrium expression it looks like this. In the numerator we got the concentration of product, and in the denominator we got the concentrations of the two reactants. And this fraction is called Q, and and this means that K is equal to Q at chemical equilibrium. So if K changes, Q need to change in the same way as K, otherwise it wouldn't be a chemical equilibrium. So Le Chatelier's principle says if a factor that affects the equilibrium is changed, the equilibrium will shift in the direction that reduces the change. This means that if a factor affecting the chemical equilibrium is changed, then the chemical equilibrium will respond in a way that reduces the change. And in reference to our experiment, we can look at test 2.1. We added 1 spatula of iron 3 nitrate, this one, a solid, which increased the amount of iron 3 ions. And the arrow tells, which gave us the equilibrium expression as this. And the arrow tells if the concentration has increased or decreased. And because of Le Chatelier's principle, it will reduces the change by using iron 3 ions and thiocyanate, which by forming the product right here. So it ends in a small decrease in the reactants and a little increase in the product. Test tube 4, where we added a few drops of silver nitrate, and thiocyanate decreases because, as we can see right here, because of this arrow, because it reacts with silver nitrate, and we saw the red color disappearing. It started to look like this, but then it became milky white precipitate. So according to Le Chatelier's principle, the equilibrium wants to reduce the change by use some of the product to produce thiocyanate again. This results that the solution became white precipitate, which means more reactants are formed at the product. At test tube 5, we know that heating up the solution makes a rate of reaction increase, and the reaction is getting faster. And the temperature affects K, the equilibrium constant. And in this experiment, K has decreased because of smaller number in the numerator and a bigger number in the denominator. So K has decreased, and therefore Q must decrease as well. Q is equal to K again, so Q is equal to a new K, so a new chemical equilibrium is established. And according to, we saw that the solution became orange, as we can see right here. This is the equilibrium mixture. And according to Le Chatelier's principle, says adding heat, the reaction will reduce the heat by using it. And because the solution becomes lighter red, the reaction to the backward reaction must be faster and endothermic, because an endothermic reaction uses heat, and the backward reaction is exothermic. So test tube 6, cooling down the solution makes a decrease in rate of reaction because K changes depending on the temperature, and in this case K has increased, so therefore Q increases as well, and Q is equal to a new K, so a new equilibrium expression is established. And according to Le Chatelier's principle, by adding cold, it wants to reduce the change and therefore use the cold, and it could use cold by making exothermic reaction. Because we have cooled down the solution, both the reaction have become slower, but one a bit slower than the other because the solution has become slightly darker, as we can see, which means there are more products in the solution, so the forward reaction is faster and exothermic. And yeah, this is a picture of all our experiment in one. So does dilution stress and equilibrium system. The cylinder, these one, are filled up with potassium permanganate. Before dilution, this one is before dilution, it looks purple, and this one is also before dilution, they look like the same color, purple. But if we look after dilution, it becomes a little bit more pink, but after dilution, see from the top, it looks like the same as before dilution. And it does that because we look through the same number of molecules. In our daily life, we can compare it to when we dilute our juice. It looks lighter from the side of the glass, but if you view it from the top, it will still be dark as before dilution with water. So, and yeah, this is because we look through the same number of molecules, but they have just moved. We took our solution, and this one is for dilution, and this one is before dilution, and it's just look the same color, and we can see it has become slightly lighter red, and the same after the dilution seen from the top. And this is because a new equilibrium is established. K is equal to Q, which results in more reactants that products become it has been lighter. And therefore the backward reaction must be faster than the forward reaction, and we end up with a lighter color, and we look different through different number of molecules. So we times a half with a half because we double up the volume, and then the concentration must go be halved. Thank you for watching.